Hi, Dykstra here again, doing a quick little video on the mean value theorem. So here we go, a little calculus action for us today. So check it out. The theorem states if f is continuous on the closed interval of a to b and is differentiable on an open interval of a to b, then there exists a number c such that f prime of c is equal to f of b minus f of a all over b minus a. All right, well, let's talk about these two things quickly, or three things actually. There are three criteria. One is it's got to be continuous. So that means, again, can't pick up your pencil. There can be no vertical asymptotes, horizontal asymptotes, things like this. It has to be somewhere where it is differentiable, meaning we can't have something that doesn't exist. Sometimes root functions, rational functions, these things where the function might become undefined at a moment. So we want to make sure we're okay there. And differentiable, meaning can we take the derivative, right? Do we know that there can be a derivative found if we are looking at that line? In other words, it can't be a horizontal line. All right, so that's those two conditions on the closed or open interval there. If that happens, we will find a c such that if we take the derivative with that c value in it, then it will be equal to f of b minus f of a all over b minus a. All right, well, this is a glorified view of the old y2 minus y1, right? This is really just y2 minus y1 all over x2 minus x1. That's really what that is. Because that's what you're doing, is you're taking the value of the b and the y value of the b minus the y value of the a, subtracting the two x's. And there you go. All right, so let's look at a quick picture. What does it look like? What the theorem states is that, again, if we have some function, the blue curve, and I'm looking at some interval a to b, then I should have a secant line, right? A secant line is a line that cuts through the curve, okay? That slope should be equal to the tangent line, all right? So f of b minus f of a, that's where we get our secant average. The average of the secant line is equal to some instantaneous rate of change, or the derivative. So you'll notice that if we have some curve, and I choose an a and a b, and in there, if we draw that secant line, somewhere on this curve will be a slope that is parallel to the secant line. So you can see if we start here at A, and I slowly curve down, that's not parallel, that's not parallel. Pretty soon, we get going, and what I want to do is I want to find a parallel line just about there, and oh, look, that looks about right there. Because if I keep going up and up and up, no, I become unparalleled. I'm going to be intersecting soon enough. So that would be our c value. All right, well, what do you have to do to solve the problems? Well, first, steps, you want to find f of b minus f of a. All over b minus a. You want to get that value. Then you're going to find f prime of x. So take the first derivative. Then you're going to set the two equal to each other. Okay? So we're going to get f prime of x is equal to f of b minus f of a. You're going to get two sets of values. This will have an x in it. This will be a number. All right? Then you solve for your x, and that will be your c values. All right, let's look at an example. If we have f of x is equal to 6x cubed, and we're looking at the interval of 1 to 2. Again, step 1, f of b minus f of a all over b minus a. That's f of 2 minus f of 1. Remember, this is your a, this is your b, right? First letter is always your a, the next one's your b. Then, if you plug in 2, well, 2 cubed is 8. 8 times 6 is 48. And you're going to subtract 1. Well, that's just 6. And then 2 minus 1. So we end up getting 42 as our value. Find the first derivative. First derivative is 18x squared. bring the 3 down. 3 times 6 is 18. 18 squared. Step 3, set those two equal to each other. And step 4, we start solving for x. And what we get is anytime we take the square root of an x squared, recall, if I take the square root of this x squared, take the square root of that, then I got to remember the plus or minus. Now, what we want to do next is try and figure out, well, which one do we want? Do we want the plus or do we want the minus? So now, which value do you want, the plus or the minus? We have to look at the interval. Go here to our interval. Our interval is from 1 to 2, right? 1 to 2. So, do we want the negative? No, we don't. We don't want the negative. We only want the plus. So, we will then have positive root 7 over 3. All right, let's look at one more example. Here we have f of x is equal to x cubed plus 2x plus 4. And again, step 1 is to find f of b minus f of a. So we do that, and we end up getting 3. Okay? Then we take f prime of x is 3x squared plus 2. Remember, bring the 3 down, reduce the power, plus 2x. 4 is a constant, so the derivative of that is 0. So we get 3x squared plus 2. Now, I need to set that equal to 3. So we do that, and then, because this is our first derivative, set it equal to the value in the f of b minus f of a business. And then step 4 is we start to solve for x. And what we end up with is x is equal to the square root of 1 over 3. And now we have to determine, once again, do we want a positive value or a negative value? So again, which value do you want, the positive or the negative? Well, in our interval, they only want from negative 1 to 0. So what we're going to do is we will choose the negative value. So the positive goes away, and you're left with negative 1 over 3 as your C value. All right? Well, this has been another Calculus Minute brought to you by Dykstra. I hope you're having a great day. Thanks again. Have fun with math. Math that like button.